Okay, so really the intention of my presentation is to connect the medical science to the practicalities of what happens on the construction site, and then to what we do to solve what is really a very easily solvable problem. And then it's closely followed by Mark from 3M, who goes into the PPE aspects of things, because really if we want to completely control the whole silica dust problem on site or in fabrication shops, etc., it can't be one or the other. It can't be solved only by PPE. It can't be only solved by engineering controls. The two are very, very closely connected. And that's probably what I'm going to try and achieve with this presentation, is to point out that relationship. So just exactly what are we dealing with silica dust? I thought I'd show you some pictures of what these particles look like to kind of make it real for all of us. So let's have a look. The particles that you see in the middle of this in the middle of the screen, these are undisturbed crystalline silica particles in Sydney sandstone. Okay, so they're really just very small, very hard rock. And that's what quartz means. Quartz means hard in German. So it's just really hard, crystalline silicon dioxide particles, right? Now, you also get that in many construction materials, because silica is a very large portion of our Earth's crust, about 55% of our Earth's crust. So anything that you quarry, it's going to contain silica, and it'll find itself into construction materials in one shape or form. And so this is an example of crystalline silica in concrete. So your same small, angular, very hard particles. Then what happens when you disturb it? When I say disturb, I mean what happens when you cut, grind, drill, and break, etc. Well, it just really breaks up into smaller, hard, angular particles. And so here's a picture of a crystalline silica particle that we took out of a P2 face mask. So that's what, when you're wearing a P2 face mask, those are the things that you are capturing, and you really don't want those getting any further than your P2 face mask. And we've been through the science of what it does when it gets inside the lungs. So during the break, I quickly hid my rather amateur slides in comparison to the medical view. So we won't go through that again. But I wanted to make a few points here, right, on this topic of where do you find crystalline silica particles. And it's across the range of building materials in varying proportions. That question earlier, how much of it is in fiber cement board? And the answer is it's quite a lot. It's anywhere between 20 and 60%. It really varies according to manufacturer. And manufacturers will be putting those kind of, or do put those kind of percentages in their MSDS sheets. So you've got a pretty good idea of what you're dealing with. So something as innocuous as fiber cement board, you kind of wouldn't think you'd find crystalline silica in it, but it's there, and you've got to deal with it. Now, another thing we need to be pretty careful of is that we've got really two forms of exposure to silica dust, whether it's in a fabrication shop or whether it be on site. One where it's generated, when you initially cut it, grind it, or break it, get big clouds of dust, and then that dust eventually settles. And then it can be redisturbed, and that's secondary dust. Now, those dust particles aren't as reactive as the dust when it was first cut, so it's not quite as dangerous as thought, but it nevertheless is a danger. And that's why we find in many key building sites, many key builders have actually banned sweeping, and they now just insist on cleanup by vacuum cleaners, because blowing anything is just redisturbing that hazardous dust for somebody else to ingest. Another key thing to point out, right, is this aerodynamic effect. Now, if I dropped a 10 micron silica particle, now a 10 micron silica particle is in that respirable range, right? So that can go deep into your lungs. If I dropped it here, 1 meter above the ground, it would take quite a few minutes. Got it there? It takes 5 minutes to settle. Well, that's really important. So you can be working all day, and you think you put your tool down, and the dust is just miraculously going to disappear. It actually takes some time for it to eventually settle. So you are, most of the time on an active building site, you are generally exposed to respirable crystalline silica dust particles. Right, so how much is generated how much dust is generated as a function of different applications? Look, it varies hugely, and this points to the previous point of like what impacts the onset of silicosis. It's all about intensity and duration, or the sheer flux of particles in the environment. So there are some real watch-outs on a construction site per application, what you really need to control very well. So we see things like when you're doing wall chasing, for example, that generates a huge amount of dust. So you simply can't do any amount of wall chasing without having dust extraction equipment fitted to that tooling. Another watch-out is heavy drilling. If you're drilling, large diameter holes, maybe you're doing post-install rebar or large anchors, that's another watch-out because it really does generate a huge amount of dust. So that's how we're sort of linking the medical science to the practicalities of what you see on site. Another watch-out is grinding, particularly in enclosed spaces. For example, you're cleaning up stairs in an enclosed stairwell. You're going to be just generating yourself a cloud of dust to work in that's not going to settle out really quickly. That's something to watch out for. Right, so really how do we solve this? The first thing to look at and see is, do I really need to do any of this cutting, grinding, drilling, or breaking? There's a number of technologies available for us to even completely avoid post-installed anchors or any kind of rework of concrete, sandstone, etc. So you can look at technologies like, instead of post-installed anchoring, casting in channels, which involves a lot of pre-work with your formworkers and that type of thing. That's a way of completely designing out any need to disturb silica-containing materials. Other options are doing things like shooting in light-duty fittings instead of drilling and post-installed anchoring, again, avoiding the need to disturb the material. But really where the industry is at is this whole piece of adopting engineering controls to capture silica dust during machining operations. And I'll just run through a few of them, the kind of things that can be done. So with processes like cutting, we can fit dust hoods to tools. The vast majority of power tool suppliers have got dust hoods or vacuum cleaners to fit to tools. We can do that for slitting. And again, slitting is a real watch-out because it generates a lot of dust, and most of the time it's done in the enclosed spaces. So this is an application which is easily solved. And of course, we can move to wet cutting. Wet cutting can be done with handheld petrol saws, and now wet cutting electric tools are available to completely mitigate airborne dust when you are machining. Grinding is a very easy problem to solve as well, just by fitting hoods to existing tools or by getting tools that are specialized concrete grinders as well. And then exhausting dust during drilling. This is again for the services industry, for the services trades. This is a very easy problem to solve as well. We're talking about plumbers, electricians, builders doing renovation work. Again, it's a watch out because it's in an enclosed space and particles can build up if they're not being captured at source. So with the help of my colleague Neil, we're going to do a very quick demo and I'll show you the efficacy of these kind of products. Right, so Neil's just going to do just touch on and watch the dust fly. So the light is illuminating. Can you see the dust floating away? Yeah? Did you see it? I won't blow it. But now Neil is going to do it with an on-tool dust extraction system on board. Okay. And again, when he wasn't going all the way through, yeah. Thanks, Neil. You can see how effective these types of systems are. Now this is can you switch the light off? This is known as the Tyndall effect. It's not to be confused with the Tinder effect. This is the Tyndall effect. And the reason why I got Neil to do this demo is twofold, right? Firstly, to show the efficacy of on-tool dust extraction, but also this is a very handy way of when you are assessing a site, as if you're an HSE officer, you've got that type of role, is to walk around with a light. It's a very simple thing to do, and shine, and see how much dust is in the environment. Because the naked eye, it just simply can't pick up very small dust particles floating around. It's a very useful thing to do. It was done by the coal miners, I think, many years ago to look at where gas was coming out of coal seams. Another thing to do is to actually capture dust at the very source when it's being generated. So you can actually get drill bits that are hollow through the middle that suck the dust right at the cutting head all the way connected to a vacuum cleaner, which is a very effective way of doing it. Diamond coring is a great example of completely avoiding drilling as well. So instead of dry drilling, you effectively wet cutting, and that's a great way to avoid generating heaps of dust from drilling. Dust can even be extracted during braking by fitting hoods to breakers, which are then connected to vacuum cleaners. But really the question is, how effective are these controls? Now we're trying to link the working exposure standard to how much dust these systems emit, to see how effective they are, and connect that to how long workers can be exposed to these applications and what kind of PPE they need to be wearing. So we do these experiments at a custom-built lab in our development center in Kaufering in Germany. We do them in worst-case scenarios, so like in an enclosed space, and just cutting meters and meters and meters and meters of concrete. So in this concrete cutting kind of example, after solid cutting for about an hour, we generated a dust concentration in that room of 0.3 milligrams per cubic meters of silica dust. That's way over an acceptable limit. And the new acceptable limit is 0.05 milligrams per cubic meter in an 8-hour period. And this is in a 1-hour period. So really the central message is here, you've got no choice when you're doing any kind of concrete cutting, even if you are using extractive technology, but you really need to be wearing those masks, which puts a reduction factor of about, if it's a P2 mask, of about 10 onto that overall dust concentration. So to the user, if you're wearing a P2 mask, you could be going, in this example, from 0.3 to 0.03 in a 1-hour continuous cutting operation. But what it also tells us with this kind of data is then you've really got to watch out for the people in the environment walking around, people who are cutting concrete, working on concrete. So that's another sort of developing story that we need to be careful of when assessing workplaces. This concrete grinding situation, this is a very good news story, because if you have the right gear, it's a very easy problem to control. So in the kind of test that we've done with concrete grinders, just working again, really working the machine at about 90% power for an hour period, it generates a lot of dust, 1.5 kilos of dust. It results in a silica dust concentration of 0.04 milligrams per cubic meters, which is underneath the new exposure standard that's been looked at. But still, if you want to be completely sure working over a full day, it really means that worker needs to be utilizing like a face mask at the same time to bring them well underneath any actionable level. And then our favorite that we just looked at, that Neil helped me with, as soon as you fit these kind of small drills with onboard extraction units, you really control the dust situation extremely well. Because for plumbers and electricians working overhead on top of scissor lifts, the hidden danger here is that your breathing zone is really, really close to this application. So if any dust is escaping from that ceiling environment, it's just going straight into the nose or straight into their mouths. So by using on-tool dust extraction, you're able to get underneath the working exposure standard, and then combine that with the necessary PPE, then you an order of magnitude again lower, which protects the user. A central piece of the on-tool dust extraction story is vacuum cleaners, right? If the unit is not self-powered, as you see in this example, and you're relying on a vacuum cleaner to pull out the dust, we really need to pay a bit of attention to the types of vacuum cleaners that are being used. So many of the WorkSafe bodies around Australia recommend an M or an H-class vacuum cleaner. And indeed, in Queensland, they recommend an H-class vacuum cleaner for when working with engineered stone. But for construction trades, it's generally accepted that an M-class vacuum cleaner does the trick. But what's different about it compared to a regular vacuum cleaner? That M-class machine, it just has a better filter, and it has an alarm built in. All suppliers who supply M-class vacuum cleaners, they have these types of alarms that beeps when the filter is clogged up. Now, the thing about talking to groups of people around the country, we really always need to give a bit of education about what's important with vacuum cleaners. And this really is the most important thing with a vacuum cleaner, is really good maintenance of its filter. It's just, I think when people look at a vacuum cleaner, they see it as a black box. It's self-contained. I plug it in, I use it, I leave it, it's okay. The truth of the matter is you've got to take very good care of these things, because this is what's standing between the very fine particles getting out into the environment and into your lungs. That's a watch out. Bagging dust is really important, because what we've found is that when we've looked at reports of occupational hygienic assessments that have been done on site, most of the highest readings are from labourers and cleaners, from emptying vacuum cleaners into skips. So they take a vacuum cleaner without a bag, upend it, and get covered in a huge plume of dust. So it's real important to bag the dust. It's the simple things, isn't it, that trip us up. But then finally, I just want to end off with this piece, really. Controlling dust, whether it's in fabrication shop, whether it's on site, is a tremendous win-win for two reasons. Firstly, because you're controlling dust at source, you're avoiding a cleanup, and that's very time-consuming, and it's a waste of skilled labor. But in the second instance, you actually extend the life of your tooling, because all of the tooling, whoever supplies you your tooling, it's got air vents built in it, and that tool happily pulls dust through itself to keep itself cool. And you can imagine that dust does no good to the internals of any machine. So really, it is a win-win. And the final part of this win-win picture is quite fundamental, really. You know, dust is a frictional element, right? So if you can remove it at source, it speeds any operation up. So it's one of those health and safety topics that if you can solve it, you win, not only with the health of your workers, but with the health of your business. So yeah, thanks very much for your attention, and if there's time for any questions.
Any questions? Yes, Mick?
With regard to wet grinding, you mentioned as a possible control measure. You get a residual dust from that. How would you control that thereafter?
So I'm hearing the question, what about the residual dust, like after grinding or after cutting? And that's a really good question. And it's about controlling the environment around. What I see a lot of contractors doing now is getting hold of secondary cleaners or air cleaners, which is a further filter. They just look like small aircon units. The likes of Husqvarna sell them, and that does the final cleaning. And when I speak to contractors who've been using those types of machines, their workers actually report a better working environment. It smells better, they say, and they feel better, probably because they can breathe better, I'm not sure. But that's another positive thing.
When that dries out, don't you then become that secondary...
Sorry, from wet grinding.
Wet grinding, yes. That slurry left over, which is your crystalline silica dust in there.
Okay, yeah, sorry, I'm a little hard of hearing. Yeah, that slurry is a watch out. Now, the studies indicate that the dust particles are at their most reactive and their most dangerous as they cut, because they almost sort of see it as atomically sharp. And they become less reactive as the surfaces become oxidized when they're left down. So they're probably not as reactive, but nevertheless, you know, you'd rather not be breathing in that stuff than breathing it in. So it's just generally good practice to be sucking up that slurry, you know, whilst grinding or whilst coring or whilst wet cutting.
Roman? Very quick question.
One of your earlier slides, and they had demolition and the amount of so the figure I think of 6, something of that order, is that from the tool work or from the collapse of walls or both?
Oh, that was solely from the tool work. So it's solely from the dust that's liberated once the concrete is breaking.
Your things?
Yeah, from the chisel thundering away at the workpiece. Yeah.
We're going to have to move on. Thank you, Martin. Very, very interesting. Thank you.